Exercise 1.2, question number 3. Find the derivative of the inverse of the following functions and also find their values at the points indicated against them. First function given is y equal to x raised to 5 plus 2x cube plus 3x. At x equal to 1, we have to discuss the derivative of the inverse function. Differentiating with respect to x, we get dy by dx equal to this power 5 will come down and power 5 will get decreased by 4. Therefore, derivative of x raised to 5 is 5x raised to 4. This 2 constant as it is, this power 3 will come down, that get multiplied with this 2, it will become 6 and power will get decreased by 1. Therefore, derivative of 2x cube is 6x square. This 3 along with a variable, that is constant along with a variable, is as it is, and derivative of this variable x is 1. Now, derivative of inverse function is always equal to 1 upon dy by dx. See here, dy by dx is always equal to 1 upon dx by dy. Therefore, we can write dx by dy is equal to 1 upon dy by dx. Okay. In place of x, we can write f inverse of y. So, derivative of f inverse of y is equal to 1 upon dy by dx. X is equal to f inverse of y because y is equal to f of x and therefore x is equal to f inverse of y. Therefore, we can conclude that derivative of the inverse function of y with respect to y is always equal to 1 upon dy by dx. So, here also we will write that derivative of f inverse of y with respect to y is equal to 1 upon dy by dx. dy by dx here is 5x raised to 4 plus 6x square plus 3. Derivative of inverse function at x equal to 1 now. In place of x, we will put here 1 and we will get the answer as 5 plus 6, 11 plus 3 as 14 in the denominator, 1 in the numerator as it is. Answer is 1 by 12. Next, Roman 2, y equal to e raised to x plus 3x plus 2. At x equal to 0, we have to discuss the value of the inverse derivative of inverse function. Differentiating with respect to x, we will get dy by dx as derivative of e raised to something, e raised to that thing. Derivative of e raised to x is e raised to x. 3 constant as it is, derivative of x is 1. Now, derivative of inverse function of y with respect to y is 1 upon dy by dx. dy by dx is e raised to x plus 3. Now, derivative of inverse function at x equal to 0 is, in place of x we will put 0 here, that will be 1 upon e raised to 0 plus 3, e raised to 0 is always 1, 1 plus 3 is 4 in the denominator, 1 in the numerator as it is. Derivative of that inverse function at x equal to 0 is 1 by 4. Roman 3, y equal to 3x square plus 2 log of x cube. At x equal to 1, we have to discuss the derivative of the inverse function. Differentiating with respect to x, we will get dy by dx as derivative of 3x square will be 6x. 2 the constant as it is, derivative of log of something is 1 upon that thing. Therefore, derivative of log of x cube is 1 upon x cube. Derivative of x cube is 3x square. This x square and x square in the denominator will get cancelled, but still 1x remains in the denominator. Therefore, 6 upon x it will be. So, dy by dx will be equal to this 6x plus this 6 upon x. We will simplify this. 6x into x will be 6x square. 1 into x, 1 into 6 will be 6. Therefore, 6x square plus 6 upon x is the dy by dx. Now, derivative of inverse function of y with respect to y is always equal to 1 upon dy by dx. That is 1 upon 6x square plus 6 upon x. So, we can have it as x upon 6x square plus 6. Okay. Now derivative of that inverse function at x equal to 1 is, in place of x now we have to put 1 here. Here also we will put 1. So it will become 1 upon 6 into 1 square plus 6. 1 in the numerator as it is, 6 plus 6 in the denominator will give you 12. Therefore answer is 1 upon 12. Roman 4, y equal to sine of x minus 2 plus x square. At x equal to 2 we have to discuss the derivative of the inverse function. Differentiating with respect to x, derivative of sine is always cos. Derivative of the angle x minus 2, it is 1. So derivative of sine of x minus 2 is now cos of x minus 2. Derivative of x square is 2x. Now derivative of inverse function is always equal to 1 upon dy by dx. dy by dx here is cos of x minus 2 upon 2x. We want to find out the value of the derivative of inverse function at x equal to 2. Therefore we will place here 2 in place of x. So 2 minus 2 will give you 0. Cos of 0 is always 1. This 2x, that will be 2 into 2, it will become 4. So 1 in the numerator as it is, in the denominator it is 1 plus 4, 5. So answer is 1 by 5. Question number 4. F of x is given as x cube plus x minus 2. We want to find the derivative of the inverse function. This dash indicates the derivative. Derivative of the inverse function at x equal to 0. So f of x, we will differentiate it and we will get f dash of x. Derivative of x cube is 3x square. Derivative of x is 1. Now we know that derivative of the inverse function is always equal to 1 upon dy by dx. Same thing, but notification is different. That derivative of inverse function we can write it as here. F inverse y raised to dash means derivative of inverse function of y. It is nothing but 1 upon f dash of x, that is 1 upon dy by dx. F dash of x here is 3x square plus 1. Therefore derivative of inverse function of y at x equal to 0 is, in place of x now we will put here 0. 1 in the numerator as it is, 3 zeros are 0 plus 1 will be 1. So 1 upon 1 will give you 1. Now using derivative we want to prove that tan inverse of x plus cot inverse of x is pi by 2. Let us check derivative of tan inverse plus cot inverse. We know that derivative of tan inverse is 1 upon 1 plus x square. Derivative of cot inverse is minus 1 upon 1 plus x square. Denominator is same. Therefore we can add the numerators. 1 plus minus 1 will give you 0. And hence the derivative of the LHS is 0. Now derivative of pi by 2, which is a constant, it is 0. As derivatives of LHS and RHS are equal, therefore we can write that tan inverse plus cot inverse is equal to pi by 2. Tan inverse of x plus cot inverse of x equal to pi by 2. Now Roman 2, sec inverse plus cosec inverse is equal to pi by 2. We want to prove this. Derivative of sec inverse plus cosec inverse. We know that derivative of sec inverse is 1 upon x root of x square minus 1. Derivative of cosec inverse is minus 1 upon x root of x square minus 1. As these are opposite numbers, addition of opposite numbers is always 0. But here mod of x is given as greater than or equal to 1. If it is less than 1, then what will happen in the root here? The thing which is less than 1, square of that will also be less than 1. And this thing minus 1 will give you this negative sign in the root. Root of negative number is not possible. Therefore care is to be taken that mod of x should be greater than or equal to 1. We have that derivative of sec inverse plus cosec inverse as 0. Now we have to get the derivative of pi by 2. Derivative of pi by 2, which is constant, is also 0. As derivative of left hand side and derivative of right hand side is equal. Therefore, we can conclude that sec inverse plus cosec inverse of x is pi by 2. That is, sec inverse of x plus cosec inverse of x is pi by 2. Now, question number 6. Differentiate the following with respect to x. Y equal to tan inverse of x. First of all, we want to find out what is derivative of tan inverse. We want to know the derivative of tan inverse is equal to 1 upon 1 plus x square. Similarly, here also derivative of tan inverse of log of x, 1 upon 1 plus x square. Here it is log of x square. Derivative of log of x is 1 upon x. Okay. So final answer will be 1 into 1 in the numerator will give you 1. In the denominator it will be x in bracket 1 plus log of x bracket square. Now Roman 2, y equal to cosec inverse of e raised to minus x. We know that derivative of cosec inverse is minus 1 upon x root of x square minus 1. So derivative of cosec inverse of e raised to minus x will give you minus 1 upon, in place of x we can write here e raised to minus x. So minus 1 upon e raised to minus x root of x square minus 1, that means e raised to minus x square minus 1, into derivative of this angle, that is derivative of this e raised to minus x. Derivative of e raised to minus x will be e raised to minus x into this minus 1. E raised to minus x in the numerator will get cancelled in the e raised to minus x in the denominator. Now we can write this minus x into 2 as minus 2x. Power raised to power is the product of the power. Now e raised to minus 2x is always equal to 1 upon e raised to 2x. Cross multiplying 1 minus e raised to 2x upon e raised to 2x. Root of 1 minus e raised to 2x will remain as it is. Root of e raised to 2x will be e raised to x. This e raised to x will go up and we will have the derivative as e raised to x upon a root of 1 minus e raised to 2x. By second method, which can be easier, we can write y equal to cosec inverse e raised to minus x as cosec inverse of 1 upon e raised to x. E raised to minus x is nothing but 1 upon e raised to x. Now, cosec inverse of 1 upon something is sine inverse of that thing according to the trigonometric property, that is cosec inverse of 1 upon theta is always sine inverse of theta. So function will become now y equal to sine inverse of e raised to x. We know that derivative of sine inverse is 1 upon root of 1 minus x square. Therefore derivative of sine inverse of e raised to x 1 upon root of 1 minus e raised to x bracket square into derivative of e raised to x, it will be e raised to x. So final answer is e raised to x upon root of 1 minus e raised to 2x, because this power raised to power will give you product of the powers. So e raised to x raised to 2 will give you e raised to 2x here. Now Roman 3, y equal to cot inverse of x cube. We know that derivative of cot inverse is minus 1 upon 1 plus x square. So derivative of this cot inverse of x cube will give you minus 1 upon 1 plus this x cube raised to 2 into derivative of this x cube. Once again derivative of cot inverse minus 1 upon 1 plus x square. So derivative of cot inverse of the variable is minus 1 upon 1 plus square of that variable into derivative of this inner thing, that is x cube. It will give you 3x square. So final answer will be this 3x square into this minus 1 will give you minus 3x square upon 1 plus x raised to 6. Roman 4, y equal to cot inverse of 4 raised to x. Derivative of cot inverse once again minus 1 upon 1 plus x square. Therefore derivative of cot inverse here also minus 1 upon 1 plus x square. But what is x here? It is 4 raised to x. So we want to write here, we have to write here 4 raised to x square. Now derivative of this angle, that is derivative of 4 raised to x, it will be 4 raised to x into log of 4, because derivative of a raised to x is a raised to x into log of a. Derivative of, that is dy by dx, will be now minus 4 raised to x log of 4 upon 1 plus 4 raised to 2x. Roman 5, y equal to tan inverse of root x. We know that derivative of tan inverse is 1 upon 1 plus x square. Derivative of tan inverse of x, 1 upon 1 plus x square. Here also we will write derivative of tan inverse of x, 1 upon 1 plus x square. But x here it is root x, so we have to write here root x square. Derivative of that angle inner function, derivative of root x now, 1 upon 1 plus derivative of root x square will be x, 1 upon 1 plus square of this root x will give you x, and derivative of root x will give you 1 upon 2 root x. So in the numerator 1 ones are 1, in the denominator 2 root x in bracket 1 plus x. Roman 6, y equal to sine inverse of root of 1 plus x square upon 2. Differentiating with respect to x, we will get dy by dx as 1 upon root of 1 minus x square, that is this root square, into derivative of this inner function, that is derivative of this root. We know that derivative of root is 1 upon 2 root. But once again, we have to take the derivative of this inner function. Here it is 1 plus x square upon 2. This 1 by 2 is the constant thing. It will remain as it is, and derivative of 1 is 0 and derivative of x square is 2x. In the meantime, we will simplify this root as root square will be, root and square will get cancelled, and 1 plus x square upon 2 it will remain, and we can simplify this as 2 ones are 2 minus 1, that will give you 1, this minus x square. Let us see, this 2 and 2 also will get cancelled. Here it will remain now x. Okay, now see this 2 ones are 2 minus 1 minus x square upon 2 as discussed earlier, into this 1 by 2, this 2 and 2 has been get cancelled, x upon this root of 1 plus x square upon root 2, we will write it separately. Okay, this, because this 2 minus 1 will give you 1, 1 minus x square it will be, here it will be root of 1 plus x square. We can multiply this inner things inside the root, 1 minus x square into 1 plus x square, it will give you a plus b into a minus b, it will give you a square minus b square, that is 1 square which is 1, x square square which is x raised to 4, this root 2 into root 2 will give you 2. Now this 2 and this 2 can get cancelled, because this x upon root of 1 minus x square upon 2 will give you x into 2 upon root of 1 minus x square. Then that 2 and 2 will get cancelled. What remains behind is x upon root of 1 minus x square. Okay, now next question is question number 7. Y equal to cos inverse of 1 minus x square. Derivative of cos inverse minus 1 upon root of 1 minus x square here, into derivative of this inner thing. We will expand this bracket as 1 minus 2x square plus x raised to 4. Okay, This 1 minus 1 will get cancelled. Plus 2x minus x raised to 4, it will be plus 2x square minus x raised to 4. This minus 2x into minus 1 will give you plus 2x. X square we can have common inside the root. What remains is 2 minus x square. Root of x square will come out of the root and it will become x. This x and x will get cancelled, hence the answer. Now, Roman 8, y equal to sine inverse of x raised to 3 by 2. Derivative of sine inverse 1 upon root of 1 minus x square. So, here x is x raised to 3 by 2, its square, it will give you x raised to 2. But we have to take derivative of this x raised to 3 by 2 also. So, 3 by 2 will come down and power will get decreased by 1, it will become 1. 3 by 2 minus 1 is 1 half. Sorry. Here x raised to 3 by 2 raised to 2, this power raised to power, product of the power, it will give you x raised to 3 only. Now the final answer is 3 root x upon 2 root of 1 minus x cube. Roman 9, y equal to cos cube of cos inverse of x cube. We can write in simpler form cos of cos inverse of x cube raised to 3, because cos cube of theta is always cos theta cube. Similarly, we can write here cos cube of theta as cos theta cube. Now it will become very much easier. Cos inverse can get nullified and x cube remains here. X cube raised to 3 is x raised to 9 and derivative of it will be 9x raised to 8. Question number 10, y equal to sine raised to 4 sine inverse of root x. Same thing we will do, that sine raised to 4 theta is nothing but sine theta raised to 4. Okay. Now the function is sine inverse of root x. It will give you root x raised to 4. Root x is nothing but x raised to half raised to 4. Power raised to power, product of the power. So it will give you x square now. Derivative of x square is 2x. So if you like this video, you can send it to the needy students. Thank you very much. Thanks a lot.